Hey guys, welcome to Law of Sines. This is going to be how to find missing angles and sides in triangles. And as you can see, we have two forms of the law of sines equation up here at the top. So what is law of sines good for? Let's find out. So what's the point? So we use law of sines to find missing sides or angles in any triangle. Now SOHCAHTOA is great, and sine is opposite over hypotenuse and all of that, but we can only use that in right triangles, and so all of that kind of falls apart if we don't have a right angle in the triangle. Enter law of sines. And law of sines is useful if you know two angles and one side. So as soon as you know two angles in the triangle and you know one of the sides in the triangle, you can use law of sines to figure everything else out. And again, this is because we're assuming you don't have a right triangle and you can't use SOHCAHTOA stuff. So what is law of sines? So law of sines is a ratio or proportion, which is saying the sine of an angle and its opposite side. So the side of an angle and the opposite side, the proportion of these is equal all the way around the triangle. So sine of A over A is equal to sine of B over B, which is also equal to sine of C over C, or you can flip it all around. As long as you're consistent, it doesn't matter. So don't worry about being like, oh shoot, was it the angle on top and the side on bottom, or the side on top and the angle on bottom? It doesn't matter as long as you keep it the same. Okay, so law of sines is really nice. So let's see some examples of how we're going to use it. So let's solve out the triangle. I have a generic triangle here. I know one of the things is like, oh, well, how do I know where little a is? How do I know where big A is, big C, little c? And so this is a generic triangle you're going to use kind of always if you're given this like big A, big B, little a. You're like, well, where do I place these? Well, this is the triangle, the kind of generic triangle that everybody kind of goes off of. So if you want to take this down, that may be helpful. So what are we after here? We're after little b. So we know big A is 40, so this angle here is 40. We know that. We know the angle B is 60. This angle B is 60. If we really wanted to, we could solve for angle big C. We'll see that in a later example where that will become useful. And we know that little a is 12. Well, little a is this side. This side is 12. The question is, what is little b? Okay, well, I could try to, with the H right here, I could try to do some trig magic with some SOHCAHTOA, but that's going to take me a long time to try to eventually find little b. Instead, I can use law of sines. I have two angles and a side given. This is exactly where law of sines come in. So I take the opposite side over the sine, so opposite side and angle. So these guys go together. So little b over sine of big B equals little a over sine of big A. So see, we just do a cross. Little a over sine of big A. And you're like, well, where did c and sine of c come from? Well, we don't necessarily need that. We don't have to use all three at the same time. The equation is just letting you know, hey, pick whatever two opposite sides you want to use, and it all is going to work out. So little b, we don't know. Sine of big B we do know is 60. So this is equal to A, which we know is 12, over sine of big A, the sine of 40. Let's hit some cross multiplication with this. So cross multiplication, B times sine of 40 equals 12 times sine of 60. Let's divide everything in here by sine of 40 because I want little b. Sine of 40, remember sine of 40 and sine of 60, these guys are just numbers. Cancel, so I get little b is equal to whatever 12 times sine of 60 is all over sine of 40. And we end up that little b is equal to 16.2. And only because I just rounded off to the nearest tenth. And it is centimeters. So little b is equal to 16.2 centimeters, and we found that using law of sines. All right, let's see another example. So what if, let's use yellow. What if big A is 5? Okay, big A is 5. Big C is 125. This angle here is 125, this whole angle. And little c is 51. Little c is 51. The question is, what is A? Well, again, I'm given two angles and a side of my triangle. Law of sines here is perfect. If you're already asking the question, okay, well, what if I don't have that? The next video is going to be law of cosines, which takes into account, hey, maybe you have some different stuff and we can solve the triangle that way, okay? But right now we're just focusing on, hey, I have two angles and a side. So let's throw in some law of sines. So our opposites that we have is we have our big C and our little c, and our big A and our little a. So that means 51. I always like to put the side on top. 51 over sine of 125, so little c over sine of big C, is equal to little a over sine of big A, or sine of 5. Little c over sine of c equals a over sine of big A. Cross multiply, so that would be 51 times sine of 5 is equal to a times sine of 125. And again, we're going to divide both sides by sine of 125 to get these guys out of here. Sine of 125. And let's see what little a drops out to be. Let me write it over here so I'm still on some green. Little a is equal to 51 times sine of just 5 over sine of 125. That brings little a to equaling 5.4. And this is in yards. And I'm just rounding to the nearest tenth. Okay, so again, we were given two angles and a side. We use law of sines. Little c over sine of big C equals little a over sine of big A, which is what we have right here. We cross multiplied. We solved for little a. We threw this into the calculator. Make sure your calculator is in degrees. And we got a is equal to 5.4. Now, let's see, a word problem that uses law of sines. So this word problem deals with angle of depression. A man is flying in a hot air balloon in a straight line at a constant rate of 5 feet per second. So he's in here, he's in his little hot air balloon, and he's flying at a constant rate, 5 feet per second. He's also flying in a perfectly straight line, constant altitude. As he approaches the parking lot of a market, he notices the angle of depression from his balloon to a friend's car in the parking lot is 35 degrees. Okay, so he's like, hey, here's my friend's car. And somehow he noticed that that angle of depression is 35 degrees. Okay, and then he keeps moving, and it's a minute and a half later. Keeps moving. It's a minute and a half later. He looks back, so he flew directly over the car. He looks back and noticed that the angle of depression is now 36 degrees to the same car. He notices now that angle is now 36 degrees. At that time, so now he's here. This little hot air balloon. You're not going to see it because I'm writing in white. At that time, what is the distance between him and his friend? Okay, well, that would be the distance here. So that's what we want to solve for. Okay. First off, I do have two angles, but I don't have the side. I would also really like this angle as well. So if I were to do that, right, 180 minus 35 minus 36, I would get this angle here is 109. So that's going to be helpful. The question is, though, what is this side here? And how do I figure that out? Well, I knew he went a minute and a half later. So he started here, a minute and a half later, he ended here. And I know he's going 5 feet per second. So a minute and a half is 90 seconds times 5 feet per second. This is 450 feet equals. So this distance here is 450 feet. Oh, there's my side. I have all three of my angles in this case. I can use law of sines to figure out this missing side of this triangle that I've just constructed here. Notice, again, law of sines is great because I didn't need to construct a right triangle. Any triangle here, in fact, will do. So I need opposites. So here's an angle and its opposite side. And here's an angle and its opposite side. So I'm going to use law of sines on these guys. So x over sine of 35, because those guys are opposites, equals 450 over sine of its opposite angle, which is 109. Okay, let me cross multiply. So we have 450 times sine of 35 is equal to sine of 109 times x. Divide out both sides by sine of 109. Sine of 109. So these guys cancel, so now we'll be able to figure out our x. Our x is equal to 450 times sine of 35 over sine of 109. And we're also rounding to the nearest foot. So that would be 273 feet. And so the distance from the hot air balloon guy to his friend in the car that was in the market is 273 feet, which might be a little bit low, and this guy might want to gain a little bit more altitude. But even so, the kind of takeaway here is that if you can construct a triangle, if you can just get 3 points in space, and you can figure out 2 of the angles in one of the sides, law of sines will get you everything else that you need. And that's pretty cool, because previously we could only do that if we had right triangles. So law of sines now allows us to find all of these sides and angles not in right triangles. And all we need to know is 2 angles and a side, and we're all good. So I hope that video was helpful. I hope it was informative. I hope you guys enjoyed it. If you have any questions, please ask, and I'll see you guys in the next video.